we can see that with a null hypothesis of 48 inches and an alternative hypothesis of 50 inches, with a sample size of 100 children and a standard deviation of 10 inches, type 2 error for the alternative hypothesis will be about 45. The question then arises, what can we do to reduce type 2 error? This is a particularly important question because often there is a desire on the part of a researcher to make alpha, that is type 1 error, equal to 0.05, and to make beta, type 2 error, equal to 0.05 also. This is often stated as alpha equal beta equal 0.05. We can see in this figure that the type 2 error, beta, this area of the purple distribution that is to the left of the red line, is about 40 to 45%. There are essentially two ways in which we can reduce beta. The first and probably the simplest is to specify the alternative hypothesis differently. For example, going over to where we have our hypothesis stated, if we were to state the alternative hypothesis not as 50 inches but as 52 inches, we can see that the large proportion of the distribution around a true mean of 52 inches lies to the right of the red line, and only a very small part of that distribution lies to the left of that line. This is the first and simplest way to reduce potential type 2 error. However, it may be that simply restating the alternative hypothesis is not what the researcher would like to do. The researcher might truly believe that an alternative hypothesis of 50 inches is the important alternative and wants to distinguish a 48-inch mean from a 50-inch mean with alpha equal beta equal 0.05. Let's go back and rewrite this alternative as 50 inches. And now the other possibility for reducing the type 2 error is to reduce the standard error. And the standard error is a function of the sample size. So if we increase the sample size, we can reduce the standard error. Let's increase the sample size to 200 and see what the result is. When we increase the sample size to 200, we reduce the standard error to 0.7. Now, in order to set upper 95% limits on a mean of 48 inches, we would need about 1.7 standard errors, which would be about 1.2 inches above 48. So, if we go back to our figure, we would want to move the red line from where it is to about 1.2 inches above 48. This is 49 inches. This is 50 inches, so 1.2 inches would be about here. Now, we have not actually made beta equal to alpha because there is still a somewhat larger portion of the purple distribution to the left of the red line than there is of the blue distribution to the right of the red line. But we can, if we have the resources, increase the sample size further. Let's go back again to the sample size, and this time let's say that it will be 250. Now we've reduced the standard error to 0.63. With a standard error of 0.63, 1.7 units above 48 would be approximately at 49. If we move the red line to 49, we can see that we have approximately the same area under the curve representing the 48-inch mean, that is to the right of the red line, as we do of the curve representing the 50-inch mean to the left of the red line. The point then is that beta can be controlled essentially in two ways. We can specify an alternative hypothesis that is farther from the null, or we can increase the sample size to the point where alpha, the type 1 error, and beta, the type 2 error, are approximately equal, and equal to the level that we wish alpha to be, in this case 0.05.